Emphasis Solutions, Bangalore. Let me introduce a few details about our speaker. Sir has more than 11 years of experience, and previously he was working in Nissan Motors and Enrich Financial Solutions. He has done his BE in CSE from Anna University and ME in IT from NIT Warangal. He is also a trainer at Let's Upgrade and the AIML mentor at the Great Lakes Institute of Management. He is also a corporate trainer for various companies. So over to you, sir, and welcome you to this session.
Thank you for your warm welcoming. So I'll take over the session. Give me a minute, guys. I'll make my
Okay.
screen as present. Um, I
Yes.
hope that my screen is
Yes.
clear.
Yes.
Yeah,
Clear. Clear.
1 minute. Give me a minute. I'll preparing the data. So unfortunately, my personal laptop was crashed due to the TensorFlow, which I was tried just before. So that I'm trying out with my office laptop. Just now I'll be uploaded. So I'll copy this data. I'll put it here in 1 minute. So I simply keep here or else I'll put it to data science. Yeah, sorry for the delay. So good afternoon to everyone. We'll start a simple demonstration on deep learning model for a patient risk stratifications, in which we could able to implement CNN model with the help of certain machine learning techniques. I'm going to handle here how the data augmentation is going to be used, since I'm going to do some integrated approach for solving a finding patient risk analysis using a deep learning frameworks. So I'll just put a deep learning architecture and parallelly how that architecture is being converted or made it as a script. That is what Python script. All right. So I'll just do it. So let us take 10 minutes of time for the introduction, then I'll do it. So what I'm going to do now is like we are going to create a deep learning, right? Deep learning model for patient risk analysis. Let us take. So here I completely use the image data. All right. So what the data I'm going to use here, like high retina, right? So I have two category of eye retina. So it's mainly it's again uh, via the retina we are going to you know have an idea about your diabetes level. So whether your retina is affected mild or severe. That's it. So I have two set of directory of images, that is eye retina, in which I have two categories. One is mild and severe. Inside a mild, because I have taken only I think 200 images, right? 200 eye retina images. Similarly, here also I have taken some set of images. I don't know. I have just copied and pasted here, maybe 100 to 200 images which belongs to severe category. All right. So with this data, I'm going to take this data as train. Similarly, I'm going to take another directory called test. In this directory, I have again two directory, mild and severe. So here I have some set of images. Here I have some set of images. So already in the morning session, I would have told you like what is the necessity of having the test directory to validate, right? To have a how good this model is working, right? To get to know we have a test data. So I just make a deep learning model which able to classify the patient, eye retina, stages, whether they are in mild stage or they are in severe stages. Actually, the original data has a lot of intermediate stages: mild, moderate, right, somewhat heavy, something like that. But if I take all the images, it takes too much of time to train, and I can't able to demonstrate you the results in lively. So I've taken only the two category, but I'll tell you the thing what is the changes you are gonna do in script to make a multi classifications, right? So this is the agenda, right? So I don't want to take all the basics and all. So directly I go with the ANN layer. Right. We all know it artificial neural networks, which is called as deep learning. Right. So when we have more number of hidden layers, that is being referred as the deep learning architectures. So let me take here, like we have a input, right? So you have input. What is the input? I have two input, right? One is mild, another one is what it is, severe. I'll show you for your references. As you can see, you should first of all we should understand what is the directories. I can have a retina underscore high directory in which have a look onto it. I have a two directory called train and test. Inside a train, I have a two directory in which have a retina images mild. You can see these are all the okay mild attack the high retina, right? Retinopathies. So and similarly this is what severely affected eye retina. All right. So based on that, the patient should be categorized whether they belongs to mild or severe. Accordingly, the further action has going to be taken. All right. So being as a human, like because we have no idea, like because we have no idea like how was our retina, how is our retina was affected, right? Simply we'll be going out and coming out, right? So when you are finding the external symptoms, then we people used to go to the hospital and take all the test, and we get an idea whether we have this or that. All right. So before that, you just take a eye retina images, and you just give your images into this trained model. Then this model will tell you which category you belongs to. Right. Suppose your eye retina is not belonging to any of the category, then your eye retina is perfectly fine. You don't have any kind of problems at your side. So as such, you can have an idea, right? So early detection is always better to cure anything. All right. So you this is the way, and similarly have kept the same images for the test directly to validate it. That's it. All right. Now we will be uh, for your references, I'll be taking only one input as of now, because if I put the multiple input neurons, it will be confusing. So obviously we have, what is it, input. Inside it you have a lot of images, right? So let us consider one images. All right. One images, always the images is going to be a RGB. All right. Before that, 1 minute. Okay, this is input. Now we have to pass this information what you have in the input layer. All right. So I should write input layer, and then ultimately we used to get output. In between there is a you know hidden layer. Right. So I'll be creating a neurons for the hidden layers. Right. So this is what hidden layer one. Right. So the input is being passed from this neuron into this. In case if you are looking somebody else, your eye is acting as a lens wherein which the input are going to be captured, and it has to be passes to your brain. So brain is simply, it's a neuron, right? So as like this input is being passed to here, because when you're looking your whole different, like that information is being passed throughout your entire brains of neurons, because there was no medical evidence like how many neurons in your brain. So roughly 10 power, I think 13, this many number of neurons are there roughly in your brains. So to all these neurons the informations it's being given, right? So as such it's given, sure, right? And then this is the hidden layer one. So here what will happen is like the weight is going to be applied. So simply w1, w2, w3 and w4. So you have a input like x1 and so on. So here there is some computation is going to be happen. So that is what neuron calculation, neuron weight calculations. All right. So w1 x1. All right. Similarly at every neurons there should be a calculation is going on. And uh, our IMS, our objective here is like whether the neuron gets fired or not. See, when you are looking your old friend, like if you able to remember that person, you suddenly you should react it, right? So how you are reacting? So if you remember your school friends, 30 20 30 years back you met him, then suddenly you are meeting today, and if you find remember, then immediately he'll be calling them, right? So that is the actions, right? So that action is going to be done with the help of the activation function. Activation function. So every layer, there should be a activation function. The activation, according to the activation function, the neurons is trying to fire out. All right. So since we are dealing with the deep learning, so we could have, right. So one more hidden layer, I could say hidden layer 2, your input is going to be passed to all way of your things. Similarly, so this is going to be right, and and I'm sorry, and this is, and similarly, right. So hidden layer 2. So as such, you can have any number of hidden layers.
Yes.
So the hidden layers is not
Not
all.
all.
पेन ये वहाँ कहाँ पाई है
Okay. So as like this, the hidden layers are going to be connected, right? And finally, so we'll be coming up with one. Okay, this is what the output layer, right? This is what your output layer. So in this neuron, it is going to be fired, right? Whether it is going to be your input is mild or it is going to be a severe, right? So hidden layer is going to be a countless according to your outcome. You can keep on adding, and similarly, um, you know the the number of neurons is depends purely depends on your control. You can have, because I can keep hidden layer 1 as 100 neurons, here I can keep 50 neurons, here I can keep 5000 neurons. So according to the your wish, and according to how the model is performing, you could change the neurons, and according the performance is going to be captured, right? So what I'm trying to say here is like we would create the input layer. This in between, this is completely what it is. It's completely hidden layer will be constructing, and finally output layer. So since now this is the image, I'm going to perform some convolution, right? So I'll just give a walkthrough ahead. What is convolution? So let us take this is the image. So if it is a colored image, is RGB as 3 channels, right? Since I have given representation, pixel representation of grayscale images, so that it is zeros and ones, right? So roughly just imagine like one RGB, one image will have 1080 into 1080. This is the pixel size, right? Resolution. So 1080 into 1080, roughly you calculate it. I don't think so. 6 zeros, right? Put 3 3 6 zeros. I think 10 lakhs of pixels. One image roughly consists of 10 lakh of images, and giving an idea, you can see here. So what is the training cost of one images? You take one images, if you want to train, it start with 0 to 9 lakhs 99,000 pixels. So in neurons, it always will take one by one after another pixels. It won't consider all the pixels at a time. It will take the first pixels, it goes here, right? Pixel 1, and there will be a computations. Let us assume that all the layers are 100 neurons, right? You have 100 hidden layers. Let us assume that. So what is the first level of neurons? The computation cost is one pixels comes here, does computation. Second pixels comes here, third pixel, fourth pixel, fifth, till to that 10 lakhs. So how many computation is happening in this places? In these places, 10 lakh computations. Similarly, for the same image, I'll be coming to the next neuron. Here also 10 lakh computations. Here also 10 lakhs computations. Here also 10 lakhs computations. So in the first hidden layer, how many neurons that I keep? 100. So 100 into 10 lakhs. All right, 10 lakhs. You can see 100 10 lakhs of times the computation is going to be happening. So you can keep two more zeros. This is actually a 10 crore, I think. Right? So 10 lakhs into if you add two zero, it is a 10 crore. Similarly, at every iterations, right? You come here, right? Then if you go to the here also 10 lakhs, 10 crore of computations. Similarly, so you have 10 hidden layers, 10 into 10 lakhs computations, roughly 100 crores of computation is going to be happening for a one single image or training. It is due to the expensive. So we want to convolute it. The convolution is nothing but just reducing the number of pixels, which is taking forward into the computation or training of your model. All right. So this is, let us take, this is 5 cross 5, right? The 5, yeah, this is 5 cross 5. Now this 5 cross 5 I'm going to reduce as 3 cross 3, right? So we have to apply the filter. You know very well the filter. So filter is the predefined matrix of values. When you are applying the filter onto the actual images, right? So after that, this is the way of applying how the filters. So when you are applying, this is the filter we used to say kernel. When the kernel is applying onto the actual pixels, you'll be getting. So if you pass 3 cross 3 kernel onto your actual 3 cross 3, you'll be getting only 1 pixel values. You could see. So 3 cross 3 can be reduced as a 1 pixel. Similarly, throughout the entire image, this is going to be happen. All right. So you can see here, this is the computations, how the filter is going to be applied. So convolute features. 5 cross 5 now became as 3 cross 3. So you just imagine as such to the, that 1080 into 1080. So for all the pixels, the filter is, it's moving across the images, then you'll be getting a convolute images. So now, if you are applying one convolution layer, so this 1080 will become maybe roughly 720 cross 720. Again, if you are applying second level of convolution, this becomes like 320 comma 320. If you apply third time, it becomes 150 comma 150. If you apply the filters, the next time maybe 60 cross 60. If you apply again, we'll be getting 20 cross 20. So the ultimate aim is in the convolution layer is we have to reduce the number of pixels in order to make the model so efficiently. But when you are doing convolutions, we shouldn't lose the original pixel of the value. So accordingly, we have to do it. So these are the kernels which is available in the market. All right. So identity, edge deduction, sharpen, and so on. And after that, so we don't want here this one. That's it. So you can see here activation function. um, as I told before, every hidden layer needs activations because the activation function is used to whether the neuron can be fired or not, right? If the neurons is triggered, then only that input is going to be passed to the next level of things. All right. So ReLU is actually a rectified linear unit, what actually the ReLU is doing, it will eliminate all the negative into your input images. All right. So when you are applying the kernel onto your actual input, sometimes you may have a negative pixel values in the images. As you can see here, it's all the negative values in the images. All right. But there won't be any negative values in the actual images. So we want to remove all these pixels. We want to truncate it. So when you are calling ReLU, especially when you are working with images in the hidden layer, you must call the ReLU because ReLU is the best thing to eliminate or to truncate your negative values. So this will truncate all the negative as zero, as you can see here. All right. Then there won't be any negative terms or negative pixel value in the outcome of the ReLU. So that is the thing. So that's why in hidden layers always we used to keep ReLU. All right. That's it. So pooling layer is a kind of thing in that. This is the structure. So now uh, I will take you all into the answer part. 1 minute. I will go to the, yes, give me a minute. So we'll be doing, give me a minute. So this is high retina, retina, you know, classification. So using deep learning and Keros with TensorFlow. Right. Give me a minute. Okay. So initially we'll be loading some of the libraries from the Keros. I think you'd be knowing what is a Keros. Right. TensorFlow is a deep learning framework or packages. And Keras is the abstract class, or else we can say wrapper class of the TensorFlow. So all the methods are defined and inbuilt in a Keras, so you can directly make use of those methods to make the model so simple. All right. So the first step is I'll be importing the required packages from it. Okay. So from Keros dot models import sequential model. Everything is it's going to be a sequential in the Keros model. From Keros dot, then we are going to have a lot of layers. Okay, layers import. I'm going to use convolution 2D. So convolution layer I'm going to use. So that I'll be using from Keros dot. I'm going to use the another layers as max pooling. Max pooling, and from Keros dot layers import activation function, right? Import activation, then from Keros dot layers import. So I'll just call dense layer and flatten, comma a dropout. All right. So don't worry. If you, I'll be explaining all dense and flat and dropout when you are doing the script. And meanwhile, if you have any doubts, you can ask me at any point of time. So, well, if you put some questions, it's always pleasure for me to answer you all. So, what was the problem in it? Which one is sequential was the problem? Okay. Yes, now it's fine. Now I go with image augmentation. So, what is the need for doing image augmentation? When you have the very less number of images, less number of inputs, then you go with the augmentation. It will create a large amount of data set, right? So you have only 200 images for your samples, but with the 200 images your model doesn't working good. In such cases you don't need to duplicate the images, because if you do copy and paste duplicating, then there won't be any sense in the model building. So rather than if we go with the augmentation will create the large amount of data with a lot of manipulation in the images itself. You know very well the augmentations, you know things, like you can rotate the images, you can share it, you can zoom, and as such we can create a plenty of models. So I'm going to call this, I'm going to perform this, right, augmentation. So this is, I'm going to do in image, so it is an image augmentation. I'm going to import, there is a thing called image augmenter, image data generator. With this I can create a augmented images, train underscore data gen, because I'm going to create a training data, right? So that image data generator. So what are the properties I'll be using, right, to perform it? So I'm going to perform rotation range, 40-degree angle. I'll be changing the rotations, and then just width shift range 20%. So then I could say height shift range, sorry, if we put comma, then height shift range again I could say 0.2 is the 20%, and rescale is actually 1 divided by 255. Why we should do like this? Your large number is going to be converted as a fraction of values, so it is very easy to maintain, right? Range, you can give anything. I'll give everything as 20 percentage, and zoom ranges. These are the augmentation format. These are the augmentation property. Accordingly, the unique images are going to be done. Right, horizontal flip, I could say yes, true, and fill mode, I could say nearest, giving how the data, how things are going to be. Right, so I've just made it as a train data, and train augmentation, and test underscore data, because via the augmentation we'll be generating the more number of images. That's what I could take, train underscore data gen, test underscore data gen. Data gen is nothing but data generation. So in test data I don't want to make all the things. Test data is used only for what is that, only for evaluating, right? So I could only rescale it. Somebody ask a question, so why 1 by 255? If your pixel values is 240 by 255, definitely it's going to be a fraction value. If your pixel value is 120 divided by 255, fraction value. So we want to convert every pixel in terms of a fractions, right? 0 to 1. That's it. So I made that as a augmentations, right? If you want, I can show you what exactly the augmentation is going to be happen, right? Because I'll take some piece of code, because if you write everything it takes time, right? Copy it, 1 minute. All right, so give me a minute. See, I can change the images here, right? So this is the piece of code. I'll show you what is augmentation, where I can load, right? We have to load that data. We should keep it up. Where is the data? I've kept in projects, iRetina. I'll take one images from the train. I'll take one images from the train data, right? So I can take one images. That is what input. I'll be storing my output as 1 minute. I can store it as in the same places, documents and projects, right? projects, we have to create a directory over there. 1 minute. Here I could create new directory or augment image. That's it. This, as of now, this file is empty. You can see when I'm executing, the files are going to be gets augmented. All right. So um, text, then augment, right? Not showing. 1 minute. Oh, iRetina. Sorry, projects or retina, and then augment. This is the directory where I want to store my image. I want to give the prefix as what it is. It's retina, right? My prefix. It is going to be stored as a JPEG format. How many copies you want it? How many augmentation you want it? I've made it as here 50. All right. So you can see here I'll be executing and I'll be opening that folder. Right now it is executing. Now you can see that augmented image folder. Right. This is the augmentation. So how many copies I have given? 50, right? 50 augmentation I have given. So one image is being manipulated with a unique features as 50. So as such the augmentation is going to be take forward, because augmentation when you are calling the augmentation in the deep learning, so which is actually uh, used to create your images into multiple times according to the model efficiency. All right. So I make this as uh, okay. So now you got to understand what is right, what is augmentation. Now I'll go with we'll be defining the train data. We have to train. I have to define train data. What is train data? So where it was? So the train data is actually was in train. You call the data gen dot. There is a method called flow from directory. All right. So if you give like this, in which the entire directory is going to be accessed. Entire directory is going to be accessed. So we have to give the path of the file here. So I'll go here and I'll give the I'll copy the path and give it to here, and this is the train, right? This is the directory. These are the images are going to be mapped with the train data. All right. So and I make this as uh, I'll convert all the pixel size as constant 150 comma 150. All right. So or else if you have because if you are not standardizing, then every images will be in the different pixel size. It might be a problem for us. So batch size I can say 16. What is the batch size? So if I put 16, the entire images is going to be divided into 16 equal size of the images. If I have 160 image, sorry, 100 images, the batch size is 16. So one batch consists of 16 images, something like that. So it is not necessary. You could put anything. Even I could say 10. All right. So then class mode equal to binary, because this is binary classification, right? I could say binary. All right. So if I execute it, you could see here. So 413 images belonging to two classes. That is 430 images are there in mild and severe. All right. Similarly, I can copy the I can create a test data. Test data equal to test underscore data gen dot flow from directory. You have to give the path of the file. All right. So I retina, after that test. Oh, we should give and then we have to define the similar thing. Target size is actually 150 comma 150. I can take it, or since I have very less, I could say 7. Yeah, it's, we can keep 150 150, that doesn't matter. And I could say the batch size again 10 comma class mode, it's again the binary because I have only two category, 217 images belonging to two classes. So now we got it, train data and test data. All right, now we are going to build a model. All right, so what is the model? What is the model actually? uh, we take care, this is the input layer, right? First we want to create a first model, input layer, we want to create an input layer, right? So starting, pick the deep learning in model architecture. Fine, so I'm going to create a model equal to sequential. This is the way you should you will be initializing the architecture. All right, and I'm going to add the layer model dot add. What is the, what you want to add with the model? So you have to add the hidden layers, right? The first hidden layer you want to add it. All right, first hidden layer. So convolution, you are going to make use of the convolutions because since your images has huge number of pixels, so you want to reduce the pixels. If not, it takes too much of time and time to train the model. So in order to reduce the training time, we will go with the convolution. So I'm going to add the convolution layer, right? So how many neurons that I want to keep into here? So I could say, sorry, how many filters you want to use it? So I could say 32 times use the filter. I could say 32 times use the filter, right? What is the filter size? I could say 3 cross 3. And one more thing, this TensorFlow and Keras is purely black box, which means that I'll be saying 3 cross 3, but inside the TensorFlow, what is the kernel it is taking, we never know it. Right, that's the, that is the why the TensorFlow is maintaining its secret. TensorFlow is actually open source, which is owned by Google. It's a Google product. TensorFlow is a Google product, uh, but they are allowing us to make use of the framework, but they are not allowing us to know what was there inside the TensorFlow. So that's what I'll be saying, 32 times you use the filters, but 3 cross 3, but what filters according to the input? The TensorFlow uses the respective filters by its own way. All right, that is what it is, a black box. 3 cross 3. And what was our input shape? The shape of the input is actually what I've given, 150 comma 150. Since it is a colored images, I give 3 is the RGB. All right, comma activation. So what is the activation functions? Since it is a RGB value, we'll be applying the kernel. So we should use the ReLU. I've told you, ReLU truncates the negative in terms of 0. All right. So then model dot add. This is the one layer. In the same layer, I want to add pooling layer. Max pooling of, you know, I have to define what is the pool size. Pool size equal to, I could say 2 comma 2. All right, that's it. This is actually the one uh, layer. This is what? One layer. So now the model has been initialized. So that is the input. Because when you are executing via the sequential, the inputs are going to be taken. All right. So this is the first hidden layer I have created. Right. So now I want to copy the same thing. Right. I want to create a next hidden layer. I'll just paste it. I want to just change the some of the properties, or you can leave as it is. Third one, I want to increase. So here you can increase the number of times the filter is using. I could, instead of 32, I could say 64, again 32. It's quite okay. Right here, sometimes even you can go for 128. So always the filters, the number of filters usage is going to be multiplies of 2. All right. So I'm going to give as like that. So 64 here. All right. And was then I keep 32. So how many layers I have created? You can see 1, 2, 3, 4, 5. So have created a 5 hidden layers. All right. Now I want to fix what is the size of the neurons. Right. I want to define some of the things. So model dot add. So these are the layers which is quite common to all the layers. So that I'll be declaring at the end of the hidden layers. So we want to flatten. Flatten. So flatten is very simple, converting your two-dimensional array into the one-dimensional array. All right, because as I told before, when the model is building, your inputs are training. The 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 individual pixels are going to be taken and it is being trained. That's what flatten is, nothing but converting your 2D or 3D in terms of a 1D. All right. Then we have to define what is it? What is the neuron size? What is the how many number of neurons you can keep at every hidden layers? I could say dense of units. Dense of units equal to, I could say 128 neurons, right? Which means that at every uh, layer there will be a 128 neurons. So you can here you can specify, or that doesn't matter, because if you put high, if I put write your activation equal to ReLU, it means that like ReLU can be applied all the hidden layers. Model dot yeah, I want to add one more layer called dropout. So dropout is something like it's kind of a gradient descent techniques, back propagation. So if I fix your 0.5, which means that 50%, I'll be giving 50% to the maximum error rate. After that, the model won't be throughout the errors, right? So within which the model should get trained. So if we fix a dropout as 50%, which means that your model try to give lesser than the 50% of the error rate. Accordingly, it will adjust the weights and everything. So then that's it. These are the additional features or layers of the hidden layers. Now I'm going to define what was my output. So I'll be defining the output layer. All right. So for your better understanding, I could say output layer. This is input layer. This is model initialize. Okay, so output layer, what we are going to add is again dense of, all right, units is equal to 1, because I'm going to take out the outcome from the only one neurons. So my neurons is only one. in the output layer. What is the activation function in the output layer? So I shouldn't use ReLU here, because since I'm going to use the sigmoid here, you know very well, in the morning session I have taken the sigmoid curve, right? Sigmoid is always used to classify the binary classes perfectly. So I'm going to use sigmoid as the activation function here. You know very well how the sigmoid is working, right? That's it. So I have constructed the architecture of the hidden layers. We have done it, right? So I go with the next one is the compile. So model is going to be compiled. How do we compile the model? It's very simple. Model dot compile, right? We have to specify what is the optimizer we'll be using, what is the loss metrics, and what is the performance metrics. Everything we have to specify here in the compile script. So model.compile, we all know it, right? The compiling is, if you write any C programming, Java programming, things has to be compiled. So where your source code is being converted as a bytecode, intermediate bytecode, right? So similarly here I want to specify, so all the metrics. Optimizer, I'm going to use Adam is the optimizer. Adam is the adaptive optimizing principles, right? And I'm going to specify the loss. The loss is going to be captured by the binary entropy. So the Adam binary entropy, it's all already defined methods. Binary cross entropy, and we have to specify what is the metrics. I want to get out the accuracy. So Adam is the optimizer, because it is the self optimization. When you are compiling itself, the Adam is coming out, and it will try to it will try to fine tune all the hyperparameters which is possible, and it will do it and come it out. So similarly loss. So loss is going to be handled by the this method, binary cross entropy. Okay. And metrics, the accuracy is going to be calculated by the accuracy metrics. That's it. So the compile is done. All right, the uh, training the model. Train the model or execute, run. So I'm going to take the result equal to model dot fit underscore generator, right? To fit what we want to specify, what is our train data, right? What is the steps per epoch? Epoch is nothing but the completion, one forward and backward is actually one epoch. The training of starting from the first images to the last images, and come back the back propagation from last to first, that is the one epoch, right? So how many epochs I want to keep for one batches, you can specify. So I could specify here is 50. All right. Okay. So and steps per epoch is 50, and batch size, if you want, you can specify batch size is 16, right? So 50, what is that? This is 16, right? 16 times, or batch size, anything you can keep it up, or else simply you can keep as it as. So epochs, I'll be telling 10 epochs. And validation data, what is the validation data? Test data, right? That is the validation. And validation steps I could say like 20. That's it. Okay, so when we execute, your model is going to be starts training. You can see here epoch 1. So how many epochs I have given here? 10 epochs I have given. Model starts training itself. You could see here epoch 1 out of 10. How many batches I have given here? You could see here 50 batches, right? 50 steps per epoch. That's what, 42, 50, 42 out of 50. It's coming out. So it still is running. Let's wait for a while. 10 epochs has to be completed. All right, you can see here, this is the, what happens. It got hanged. Okay, let me wait for a while. Oh, so once again I'll try it out. Yeah, first epoch is going on. 50 steps every epoch. Your loss is 0.6, accuracy is 0.73. All right, similarly, I think 1 minute. I'll be just, it is not coming out. Right. Yeah. Now it will be displaying all the things. You could see here all the epochs is being done. So 10 epochs is done. Finally, this is the normal loss, the accuracy, right? And validation loss. After checking the test data, your loss is 0.73, accuracy is 0.6, right? 60% accuracy. So this is the way you can build or train a model. And let us check. Uh, let's make a graph. How was your model is performing? So import matplotlib.pyplot as plt, because I want to show you all the things in terms of a graph, right? So I'm going to print the result is the object where in which everything was stored, right? Result dot history dot keys. Yeah, what is the history keys? Loss, accuracy, validation accuracy, it will be showing. That's the thing. And I'm going to plot result dot history of what we have to specify, accuracy, and similarly plt dot plot of result dot history of validation accuracy, right? Validation accuracy. Similarly, so plt dot title of model accuracy, plt dot x label of, the x label is epoch, y label is, so we have to define y label accuracy, right? So I'm going to call the legend of, so the legend is going to be train comma test location. I can specify upper left, anywhere you can specify left. dot show. What happened? Where is the mistake? ACC. State dot. Yeah, it was ACC only. Result dot history of ACC. 1 minute. What is the uh, now it's being changed? What is the
Bracket
yeah?
missing, sir. Bracket missing.
Not a bracket. This which bracket? No, I think yeah, because this has been changed. We have to give the exact key values. Val underscore accuracy, right? And that's it. Yeah, we got it. You can see here. So as such, you can make use of this model to your research article. You can take a graph and where in which you can discuss. All right. So this is what model accuracy. Now I'm going to copy and paste it for losses. Similarly, the loss graph. So I can keep right loss. What is the loss? Loss and VA loss. So instead of here accuracy, right, I may put a loss here val underscore loss. That's it. This instead of model accuracy, I may give title as model loss, epoch accuracy, time and test. I can keep everything is okay. Let's see. This is the model loss. All right. So initially the loss is, the blue is training loss, and that brown is a test loss. And one more thing, you can even you can identify how the objects are going to be, right? You can get a model summary. Okay. When you are calling this model dot summary, it will be displaying the architecture of what you have taken, right? So this is the architecture you have designed, everything given, right? So initially convolution layer, what was our input? After first convolution input was reduced as 74 pixels, then 72, then 36, then 34. So this is what initially what is our input pixel size? 150 cross 150. When it comes out from the first convolution layer, it was 148 cross 148. When it goes to the next layer max pooling, it came out by 77 74 comma 74. And as such, when it goes to here, you can see a 2 cross 2. When the inputs are coming out from the last layer, it was 2 cross 2, but it is very poor, because we shouldn't, when you have the 2 pixels, 2 cross 2, it's a 4 pixels, you can't able to get all the pixels, right? So we should cut 2 layers so that the performance might be increasing. All right. So give me a minute, I'll cut the 2 layers. Only 2 layers is enough. Everything I'm going to cut it, or else I'll just copy this entire thing and I'll put it here, right? Reconstruction the model. So I'll be just removing the last two model, two layer, then we'll go with, right? I'll copy everything. I'll put compile, 1 minute. I'll put everything in the same place so that it will be easy for us to capture. So this is the way we can uh, run the model. Even that too I can keep here, right? Let's execute it, right? So I've reduced the 2 layers because which is unnecessary. Okay, So when I'm reducing, sometimes the performance is being decreased, but which is good. All right. So let's copy the you know this one for this reduced architecture, reduced layer of performance. All right. And training performance was good enough, but in testing performance, which is not good actually. So at last you got like 55 percentage as the accuracy. And let's see what is the losses. So the loss is going to be, all right, you can see here. So in the training loss is going to be when the epoxes are going to be completed at the end of the model training, the losses it's been increasing drastically. All right. So as like that, because you have to decrease and increase the hidden layers, you have to find out the appropriate number of hidden layers, what is required for your problem. All right, that's it. So now you can find a summary, model dot summary. You can see you have only two hidden layers. So your last pixel size was 17 cross 17. All right. So this is what how you can make a model. So any queries in it? Please let me know.
Yes, sir. Am I audible, sir?
Yeah, you are audible. Please.
Yes, sir. Actually, if I want to increase the accuracy, sir, instead of ReLU, means can I use the activation another activation functions? Means I want to increase the accuracy, sir.
And see, increasing the accuracy is it shouldn't be objective. See, because if you change the activation function instead of reload,
Hmm.
since we are using the filters inside the hidden layers, right? So obviously you should have the negative values inside your input pixels. So reload is the only activation function which truncates your negative terms as zero. So if you are not using reload, then there might be a problem which exits into your neurons, which drastically computes the weights and everything, which might not be appropriate for your problems. So when you are using the what it is image, better always you go with the reloop in hidden layers, but you can change in the output layer according to the outcome, whether you are going to get two classes or three classes, whatever it is. Accordingly you can change the activation function in the output layer. Even you can change the activation function in the hidden layer, but uh, definitely at least one hidden layer should have the redo activation function.
Okay, okay. Means for more means other than binary, means
Yeah.
when I
Okay.
go for more parameter, so after that I can go for other than ReLU, right?
Yeah, exactly.
And which parameters are means important for the accuracy
See,
in both of them?
everything matters here, right? I cannot say this is the only factor which makes the impact onto the accuracy, because how many layers you are using, that makes sense. How many neurons you are using, that makes sense. Whether you are using what is it, pooling or not, that makes sense. So
Okay,
and depends on the activation function also, the outcome gets varied. So here there was no standard technique or methods are not defined it. So
okay,
it's completely as a trial and error method. You should apply all the methods and all the possible ways, and you have to come up with different models out of which you have to pick up the best one. So that is the this is the way only to find out the best model in the artificial neural networks.
okay, okay. Thank you so much, sir. And can we will get this notebook, sir, after end of this session?
Definitely, I can share all these to the team, and then the respective team will forward you all.
Thank you so much, sir. Thank you so much. And wonderful session, sir.
Yeah, thank you.
Any other queries? Any other queries from the participants? If you have doubts, you can unmute yourself and you can ask the doubts to Pradeep sir. So thank you so much. Natation sir, do you have any doubt? So thank you so much sir for that wonderful session. And the very simple explanation, but even though the explanation was simple, you have gone very much in depth. And I think we can see 68 participants, so I'm very sure that all the 68 participants are going to work on whatever project you have worked out to us today. I'll be sharing the codes with all the participants, don't worry for that. Tomorrow we'll be sharing you all the codes of all the sessions and all the PPTs. And so thank you for so much for your time. You have spent the full day with us, that too being the end of the year 2020.
Yeah,
Thank you so much. Thank you so much for your effort and your time. From the participant side, anyone want to give a feedback to Pradeep sir? You can very well do it now. If anyone want to give a feedback, you can unmute your mic and you can give a feedback to Pradeep sir session. So all the participants are messaged thank you and excellent session. Hope Pradeep sir you're seeing the messages.
yeah, I can see all that.
So we are going to wind up with an exam. As all the participants know, we have an exam coming up. We will have 25 questions, 25 to 30 questions, and you'll be given 45 minutes time to solve this. And in fact, I can't wind up the session without thanking my team. I would like to read the names of the faculty members who have been doing all the work behind the scene. Ms. B. Ramya, Mr. Natation, Ms. Shanmugapriya and Mr. Thomas sir. So all of them have been working hard during this holiday time. Actually, this is a holiday time where not much work is there. Everyone is in the native place, but these four have worked very hard to make this event a success. In fact, from the participants' messages, I can very well understand that all of you are really happy with this program. Anyone can come forward. If you want to give a oral feedback, you can come and give your feedback if anyone wants to give a feedback.
Hello, ma'am. Hello,
If any
am I audible?
participant want to give the feedback to the
Yeah,
session,
yeah, I'm here. I'm audible.
yes, sir.
Yeah, thank you, madam, for giving me the chance to give my means. As actually from last 5 day, this session means really people are means what I don't know about other people's, but definitely hands-on session is definitely very important for the learning approach. Means we are spending 3, 4, maximum 6 hours for hands-on, and we are not get bother means definitely such type of program, such type of STP, FDP, it's very helpful for the student and faculties. And the speaker from day 1 to day 5 all are the eminent speaker from the industry, and this will be definitely helpful for our Miss Academic, as we are academician, and same will helpful for our student. Thank you so much for the all the organizer for this nice and wonderful program. Thank you so much. And madam, I request please share all the details means
Sure, sir.
day wise,
So,
session wise, if we'll get. that will be means we can
Sure,
take
sir.
more
In
learning.
fact, I am
Yeah.
more happy if you, take the takeaways from this session is more for the participants. So we'll be doing our best to share all the materials, to collect all the materials from all the resource persons and share with you. And even in future, if you have any doubt related to the code, you can get back to us and we can get you connected with the resource person also. So don't think that this is the last day and you are going to lose the
Okay. Okay.
connection with this organizing team. We always there to help you out. And in fact, I forgot to share that KCG College is a nodal research center approved by Anna University. So if you come and do PhD at KCG College of Technology, you'll have a certified PhD from Anna University. And we have more than 40 approved supervisors who are under Anna University. And we have more than 100 faculties who are doing research at the KCG Anna University Research Center. So you
Yeah.
can
Thank you.
even, all the faculty, all the participants can also plan for joint publications or joint research collaborations, always welcome. Any other
Okay.
participants, sir? Thank you so much, sir. Any other participants?
Ma'am, I would like to give my feedback. Can you hear me? Yes, ma'am.
Yes,
Can you hear me? Yes.
yes, yes, ma'am. Yes, yes, we can
Ma'am,
hear you. Yes.
yeah. This STP is very much useful and informative for me also because I got the knowledge about the programming and just how to carry out the programming as well as practical based view of this one. And this program is very much well organized and fantastic one, ma'am. And in pandemic situation, it is just a very helpful tool for us, ma'am. I hope in future you will organize more programs, ma'am. Thank you very much. Thank you.
Thank you.
Lot of
Thank
Happy
you
New
so much,
Year.
ma'am. Yeah.
Happy New Year.
Yes, Happy New Year to all the team. And yes, we are organizing another series from January 27th to February 1st. This is the third series. So if any of the participants are willing to join in the third series, most welcome. In fact, we'll be happy if the entire team is there in the third series also. So if you want to attend the next session, ma'am, you are welcome to that. That will be more advanced and it will be research perspective part of AI for help.
Okay, okay, ma'am. Okay, thank you very much. Just
Thank you.
email, sir. Okay.
Anyone else want to give the feedback? Please come forward, make this interactive. Yes.
Good afternoon, may I, ma'am?
Yes. Good afternoon.
Uh, Good afternoon to all
Yes,
participants,
yes.
resource
Good
person,
afternoon,
and
sir.
especially to management KCG, the organizers. It was really wonderful session throughout from starting of first day to the end of the session. Not only we have enjoyed each and every resource person, but it has all the people has put a deep impact on each and everyone who was thoroughly listening to the session. Every session was giving some different lookout into the deep learning, machine learning, and AI application in medical and the imaging part. And all the resource person selected were, I should surely say that they were the charm of the field which has been selected. Again, I would like to say that the management done by the organizers, especially Deepa Josmem and all other uh, coordinators, have done a wonderful job by timely doing all activities, providing all necessary required feedback, and facilitating all the people. I surely say that this is, if I want to rate the resource person, I'll surely rate the maximum as well as the management of the complete uh, this 5 days, whatever have been managed, that also has been rated as a highest one. Thank you very much from bottom of my heart. Thank you, ma'am.
Sir, thank you, sir. In fact, this thanks I'll be giving to my team. And to the resource persons, all the resource persons have given their 100%, 100% effort, and that's why we have been a good success. And as I told, we will have another series, so please join that series too.
Surely, ma'am. Thank you.
Thank you, sir. So can we go for the exam now? So we'll be, anyone else want to give a feedback can come up, or we can go for the exam now. So, yes,
Hello, ma'am.
yes,
Yeah,
please.
yeah. Good evening, all. This is Panjavarnam from Sairam Engineering College.
Okay.
So, actually, my research area is like a telemedicine in this healthcare, ma'am. Healthcare
Great.
and television using any, intelligent algorithms.
So very good
Plus,
research field you have selected, specifically something that not many will opt for and very much useful for this current scenario.
yes, ma'am. That's what, ma'am. I'm really, I'm really happy with the contents and the presentation that every expert had given. I was so happy. Like, I had really one. I think yesterday speaker. I think Mr. Dheer and Raj from Verisan, he has clearly explained the difference between ML, AI, and DL. This doubts and this confusion will be there with many of the people. Maybe by the time all the participants would have got a clear idea which is the subset of which area, like starting from AI, ML, and DL, they were clearly explaining. That was one wonderful thing to the, uh, uh, those who are in the inception stage of this ML, and those are having a medium knowledge about these areas, they may not find difficulty, but those who are in inception stage of this gaining this knowledge, able to hear me, ma'am?
Yes, very clear.
Yes, ma'am. So they had given a very clear ideas. And one another wonderful thing was that programming, the way they taught the program, that was really wonderful. It was not at all for namesake. As we felt as if we are in one laboratory, like as we teach for our students. So it's a complete package. So that one was really appreciable. Though we are very new
So
to this Python.
please join our next session too, madam.
Yeah, yeah, I'm very much impressed, Mamlu. I surely will join because it is healthcare oriented, knowledge what you have given us. So we are imported with a very crucial and very, timely need. Actually, everyone should take up some kind of research problems in the healthcare sector to benefit the society. So here in this forum, I had got a lot of knowledge from every guest. Hope for the other participants also. So I heartfully thank all the organizers. Well organized, patient answering. Even yesterday to Deepa Jose ma'am, I had put a message. I was interestingly listening to the guest lecture. I missed the attendance. Ma'am was telling, no worries, don't worry, I will paste it again. So this comfort also made us very cool, ma'am, throughout these 5 days. So thanks a lot, the team, and I congratulate the team. And we'll join you soon, ma'am, for the next webinar.
Okay,
Thank
please
you
do
all.
keep in
I'm very
touch.
happy.
Please
Yes,
do keep
ma'am.
in
Very
touch.
happy.
Okay.
Yeah, very happy New Year to all. Thank you.
Thank you. Thank you so much, ma'am, for the wonderful feedback and explanation and encouragement. Anyone else? I should not leave anyone if they want to come forward and speak. So let's go back to the exam now. I'll be posting this exam link in the WhatsApp and as well as in the Teams. Give me some time to post it, and you'll be given approximately 45 minutes. So within that, you have to finish the exam. Once again, thank you to all the participants for this patient listening and being the last day of the year, spending time for which clearly it shows that how much interested you are in this specific concept, and how much of effort and how much of sacrifice you are doing for learning this, and reflects your enthusiasm to learn about artificial intelligence. Okay, so with these words, we are going to start the exam.